Hello everyone, this is a continuation of my previous video. So if you haven't watched that, I'll attach the link in the description. You can watch that. Okay, so in this is a problem of system of parallel batteries. Now in the previous video, all the batteries have the polarity. This side is positive, 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 but here I have changed the polarity of this battery in the opposite direction. So what would be the equivalent EMF and the internal resistance? So let's see that. Now we are going to find that. Now first, in order to do that, I will first mark the current. So from this battery, let's mark the current here, I1, and from this, let's mark the current in this direction, I2, and from this, the current, let's take I3. Now from and here I'm going to mark the current I. Okay, so I can consider this junction and I can use the Kirchhoff law about current. So which is say the in a junction or not, the sigma I is equals to 0. So here current coming in is I1 and I3. So I1 plus I3, and these I2 and I are moving out from the junction, so minus I minus I2 equals to 0. So from this I can subject I, so I is I1 minus I2 plus I3. Okay, and now here I can write the voltage difference across the equivalent battery. Let's say that is V. So we can write V equals E. Now the current, if this is a equivalent battery, it should give the same electric effect that means the current should be I, because the net current giving out to the circuit from this system of batteries I. Now if I make this a closed loop, so here the current I means the same current I would be here. Okay, so I can write here V equals E minus IR, right? And from that I can obtain a formula for I. So we get I equals, so I equals, we get taking I E minus V over R. Okay, now here the voltage difference is V, therefore the voltage difference across each battery is going to be V, right? That is the definition of parallel, right? If resistor or batteries are in parallel, the voltage across them are the same. So now again here I can write voltage across this one, V is equals to E1 minus IR1, R1. Okay, so from that I get I1 equals to E1 minus V over R1, and similarly I can write for this one now, but for this second battery it is in the opposite direction, right? So EMF, now if I write the voltage difference, let's say this point is A, this point is B, so V I have taken is actually here the potential is large, so VAB it is VAB. Now for this one, I know here the potential is larger. If I consider this one comparing this point is like high potential, something like that. So VBA I can write ABA is actually, it is minus V. I'm taking the other side now. Minus V is equals to, so E2 minus I2 R2, right? and I'm going to multiply this formula by minus. So I get, if I multiply this by minus into VBA, right? So minus VBA is equals to V, so whole term minus E2 minus I2 R2. Now minus VBA is actually VAB, right? So and multiplied by minus. Okay, so from this formula I can get current I2 is equals to E2 plus V divided by R2, right? So you subject this, okay, so E2, because taking minus, so it becomes minus V here, taking, so when you simplify you will get this. Okay, you can try that. Okay, and then finally we have this one. Again I can simply write V equals E3 minus I3 R3, so which gives me the current I3 equals E3 minus V divided by R3. And now I have these three relations and this one, and I'm going to substitute into this formula. So I is actually E minus V over R is equals to, here it is I1 is E1 minus V over R1, and then we have minus I2, so minus, and then I2 is this one, E2 plus V divided by R2, okay, plus I3 is E3 minus V divided by R3. Now let's rearrange and simplify this equation. So E over R minus V over R equals to E1 over R1 minus V over R1 minus E2 over R2 minus V over R2 plus E3 over R3 minus V over R3. So I can write E over R minus V over R equals to E1 over R1 minus E2 over R2 E over R3 minus, meaning this term and this term. In these three, minus V is common, I can take my here, so over R1 plus over R2 R3. So this is, I can write E over R minus V over R equals to E1 over R minus E2 over R2 plus E3 over R3 minus V into, this is 1 over R, right? Because this is the this gives the extra, so the term is equals to 1 over R, so I can multiply just by 1 over R here. So we can see clearly this term and this term cancels and gives that E over R equals to E1 over R1 E2 over R E3 over R3. So we can clearly see that since we have polarity of this battery, we got here a minus sign.